start going over this. So with the graphing stories, again, it's going to give you a representation or a story. You're going to have to identify which graph is represented by each portion of the scenario. Or you might be given a graph and you have to create a story for that, for based off of each detail in the graph. So what we're going to do here is we're going to break this graph or this story down by each portion or each segment that's happening. So it says the air temperature was constant for the first several hours, right? Constant for the first several hours. Constant is going to look like what? When I say constant, what would that look like in the graph? What do you think it's going to start off looking like? Is the graph going to increase? Is it going to decrease? Is it going to be a flat line? What do you think? Jair? Going to be a flat line. If it's constant, it means that the temperature is not going up, but it's not going down. It's staying the same. So if we're looking at the temperature, we're wanting to look for a flat portion. So here's a flat portion. The second graph has a flat portion. The third graph does not start with a flat portion, which means right off the bat, the third graph is going to be wrong. So I'm going to go ahead and put an X through it. Because of the fact that it does not start off as a constant or a flat graph, then I know that that's wrong. Okay, then I'm going to go to the next portion of my graph. The next portion says it then rose steadily for several hours. Rose steadily. Does that mean it's going up? It's going down? It's staying flat? What does that mean? Amy? It's going up. Okay, so it's going to go up. Let's look at graph A and B. So graph A is showing that it's going up. Graph B is also showing that it's going up. So both of those are showing that they start off with a constant temperature, then they rise steadily in temperature. So they're both consistent to each other or same to each other. Okay, let's go to the next portion of the story. It stayed the same temperature for most of the day. It stayed the same temperature. What is that going to look like if it's staying the same temperature? Kelly? It's going to be a flat straight line. Is graph A a flat straight line? No, graph A is curving right here. So right here is where graph A no longer fits the scenario. Graph B does. It's got a nice flat line, just like it started with a flat line. In the center, it's got that flat line for the portion of the day. And then let's just go ahead and finish it off. It stayed the same temperature before dropping sharply at the end of the day, right? It's dropping sharply at sundown, which means it would decrease, and that's what we're seeing right here. So this graph B, the center graph, is going to be the representation of this story. This graph represents the actual story. Okay, so let's write all of that down again, what everything means that I said in each of the colors. So in green, that constant. The constant at the start meant that it was going to have a horizontal line at the beginning. Having a constant start meant that it was going to have a horizontal line. Horizontal line means it goes flat left and right. That's a horizontal line. Okay? So that's why we were able to eliminate graph 3. When we talk about the fact that it rose steadily, meant that you had a vertical increase. A vertical increase. It's going up. Again, the next portion saying that it stayed the same. When it said it stayed the same, that was again another horizontal line. And then at the end, when it said that it dropped sharply, that was going to be a vertical decrease. Okay, so that's what we're going to be doing throughout the notes today. And then when you take your quizzes assignment today, it's going to have a mixture of function or not function questions based off of graphs, diagrams, charts, or data input, and then having to connect graphing stories to their graph, or connecting graphs to a graphing story, or looking within a graphing story, like a graphed out story, and identify components that match certain scenarios, saying, okay, at what point does it increase? At what point does it decrease? At what point is it flat? Okay. Let me go ahead and flip to the next page. I'll give you guys another little situation. All right, so a person walks, gradually speeds up to a run, but then slows back down to a walk. Looking at graph A, graph B, and graph C. Person is walking, they're going to gradually speed up to a run, and then they're going to slow back down to a walking speed again. Which graph do you think represents that situation? Leo? C. Very good. So for here, if we're looking at graph A, it starts, but instead of having a time where it's actually going to be just a little walking period, it's going to drastically hop up to a run and stay at the run the entire time, right? Here, you're kind of already at a high speed of running, faster running, maybe back down to running, faster running, maybe back down to a little slower running. For here, you've got a slight portion of walk, and then it increases to a run, stays at a run, then comes back down, and then stays at a steady walk and not at a stop. Okay, so this is going to be more of a representation for that scenario. Okay, let's look at another one. All right, a flag. The flag is raised up the flagpole at a constant speed. A flag is raised up a flagpole at a constant speed. Will graph A, B, or C represent the rising of the flagpole, or the rising of the flag up the flagpole? Which one? Kaden? B. Good. See, A has it going up, tapering off for a little bit, goes up, tapers off for a little bit, goes up, tapers off for a little bit, up, tapers off for a little bit. So is that constant speed? No. That's a, let me pull it, stop for a moment. Then let me pull it, stop for a moment. Pull it up again, stop for a moment. That's not a constant speed where there's no braking in between. For here, B shows a constant rise. It's a straight line. Okay, consistency means it's going to be linear, straight. And then once it gets to that top point, it tapers off and it stays at the same height, because eventually, once it gets up to the top of the flagpole, it can't go any further, can it? It's going to stay there, and it's going to stay there for the rest of the afternoon. Okay? As C, it shows kind of a consistency until it gets close to a top, and then it starts curving and coming back down, and then it's going to be flat. Almost like they rise it up and bring it down some and then leave it where it is instead of it being up at the top. Okay, so that's not going to be what the story was indicating. So the correct answer here is going to have to be B. Okay, now again, sometimes you are going to have to identify which story would match up with a specific graph. So I'm going to go ahead and give you guys a graph, and I want you to come up with a story to match the scenario. So we're having a representation of time and water level. time and water level. And there's the graph. I'm going to go ahead and pause the video for a couple minutes, let you guys think of a scenario. You're going to write it down, and then eventually you're going to share it out with your partners next to you. Who would like to share their story? Really, nobody? Okay, who would like to share somebody else's story? How about that? Go ahead. Go ahead, Sarah. Share someone else's story. Okay. So water level being affected by the moon. So are you talking about like tide? Okay, so that does make sense. You know, because guys, there are things like tide pools tide pools that during a certain portion of the day they're completely empty, and that's when you can see a lot of stuff that's inside. But then when the tide comes up to high tide, those tide pools fill up, and it's like the whole thing comes to life. You've got fish in there. You've got all sorts of like little crabs in there. It's really, really amazing. So maybe the tide starts coming in, and for a little while during the day, the high tide stays steady. And then as it pulls out, the gravitational pull from, like he said with the moon, the tide then comes back, and the tide pool empties, okay? Something similar that maybe you might not have thought about is a bathtub, guys. If you're going to take a bath, right? You got to fill the bathtub up. Then you're going to take a bath, so the bath water is going to stay constant. You turn the water off, and you're sitting in there. You clean whatever. If you're a little kid, maybe you played with some toys. Then when bath time was done, you drained the tub, right? Something very simple as that. And we'll go ahead and write that down. So you're going to fill a tub with water. That shows that increase. Because when you're turning on the faucet is going to have a constant flow of water as long as you don't mess with it. You just pull it out and let it do its job. It's going to fill the tub at a constant rate. So that's why you have that straight linear increase, a linear increase. Okay, then once the tub is full, you're going to turn the water off. You might get inside, take your bath. Okay, then once you're done with the bath, you're going to drain the water. Again, the water drains at a constant rate. So that's why it's a linear decline. You let the water drain. So something as simple as that for those graphing stories. They don't have to be super detailed. They can be very, very easy. Let's do one more. We'll do one more graphing story, and then we'll get into our assignment. Okay? Okay, let's go over this one real quickly, so that way you guys can get into your assignment. Talking about age and talking about height. Notice I did not start the graph at the very corner. Why is that? Why do you think? Because when you're born, are you at 0 height? No, you have height to you, right? If you're like 15 inches long, 19 inches long, 21 inches long, you've got some height to you. Notice that it's got a pretty drastic increase at the start. It's because as a kid, you guys grow quickly. Okay, you guys shoot up real fast the first 18 years of your life and 19, maybe even 20 years of your life. And then what happens? You stop growing for a time period, but notice what happens here. This is probably something you don't want to know, but as you get older, you actually start to shrink. You do. As you get older, you start to lose height because bone density is changing and you're losing bone mass, and like things like your spine is no longer as elongated. You might actually hunch over a little bit and can no longer stand as straight. It's just as you're moving, you're doing sports, you're losing little bits of your bone and bone density as you age. So you actually do shrink as you get to your older age. Okay. Which is going to suck for me because I'm already short, so I'm not looking forward to that part. But the idea of this is that when you're born, you're at a certain height. At a young age, you increase your height pretty quickly until eventually you have hit your last growth spurt. You're done growing. You stay the steady height for a while till you get to older age. If you're blessed to be able to get to older age, you might just start decreasing in your height a little bit. Not a whole lot, but a little bit. Might lose an inch or two. Okay? Any questions? Fantastic. Let's go ahead and grab our computers. Your assignment has been posted into Google Classroom.